All right, here we're going to look at topic 67, example 2, where we solve a one variable inequality by graphing. So the question is, how can you use a graph to solve an inequality? In part A, they want us to solve x squared minus 4 is greater than 0. Let me clear this out from the last video. So should have anything typed in here. There we go. For whatever reason, it's still not allowing me to work with y1, but we'll live with it. All right, so you really wouldn't use this method if you were solving this equation. You would not need to graph this to solve this inequality. You could figure it out pretty easily outside of that. But it's important to understand how to read graphs or how to interpret graphs and know what the information is telling you. So I'm going to go through how to solve an inequality using a graph. Sometimes it'll be incredibly useful, and sometimes it'll be far easier to solve it using arithmetic. So what we want to do to solve the inequality, we want to identify the values of x that make the value of the expression x squared minus 4 greater than 0. So we want, think positive. Previous sections we talked about positive and negative intervals. We want things that are greater than 0, so we're looking for the positive parts of our graph. So we're going to graph the equation y equals x squared minus 4, and notice how I'm using an equal sign instead of an inequality, but you'll see why. And then we're going to translate the parent function down 4 units. I'm going to type it into the calculator. So I'm going to put in my variable of x, I'm going to square that, and then I'm going to subtract 4. You could definitely graph x squared minus 4 by hand. You should know that it's a translation down 4 units, but either way, I want to be able to look at this and see what it looks like on the graph. So if I were to hit graph, get a graph that looks like that, where I have my vertex at 0, negative 4, and then I'm going to have a couple points here. Again, we're looking to graph those, and we'll have the next point will be somewhere about here. Okay. So our graph looks something like this. And what we're looking to do is we want to determine when the value of the expression x squared minus 4 is greater than 0. It's greater than 0 anytime my graph is above the x-axis. So that's these two portions here. And that may seem pretty straightforward, it may not. But think of kind of terms in terms of positive and negative intervals. Because we're looking for greater than 0, we want positive intervals. You have this point here, which is 2, 0, and you have this point here, which is negative 2, 0. My graph is positive when the x values are less than negative 2, right? And that would cover this section over here is when x is less than negative 2. And this section over here is when x is greater than 2. So those are my solutions. I would say that it's positive when x is greater than 2 and when x, or when x is less than negative 2. Hopefully that makes sense right away, but if it doesn't, again, we're looking at these 2 points and we want things above the x-axis. So our x-axis is here. We want the portions of the graph that are above, because anything above the x-axis would wind up being a positive number. If I took the number 1, right, if I plug this 1 in here, and I had x squared minus 4 is greater than 0, and I plug in 1, well, if I do this math, I get negative 3 is greater than 0, which is wrong, right? That doesn't make any sense. And that makes sense in terms of my graph because that number's down here below the x-axis. So if I was to take any number that's above the x-axis, any value, so anything from like 2, 3, 4, 5, or less than negative 2, negative 3, negative 4, negative 5, and so on, when I plug those in, they'll keep my inequality will be a true statement. Again, is this the most accurate way or the best way to solve an inequality? Absolutely not. There are times this becomes incredibly useful. For this specific problem, I would suggest a different method. But the idea is that when the graph is above the x-axis, those portions are positive or greater than 0, and the portions below the x-axis are negative or less than 0. Right, so that'll come into play. Let me just get rid of these extra lines that I don't need so I don't get confused. All right, so that's it for part A. That's really all we needed to do. In part B, it's a little more involved because we have to come up with the equation ourselves. But they tell us a motorcycle is 40 miles ahead of a car. The motorcycle travels at an average rate of 40 miles per hour, and the car travels at a rate of 60 miles per hour. When will the car be ahead of the motorcycle? So what we want to do is we want to figure out when what are we looking for? When the car is ahead of the motorcycle. So the motorcycle started ahead. So we want to know, we're going to let X represent the number of hours. So I'm reading this part here. Let X represent the number of hours since the car started traveling. The expression 60X represents the distance the car travels in X hours, right? So if we have 60X, that's 60 miles per hour, and X being the hours, we could easily figure out how far that car traveled. Now, for the motorcycle, the expression 40X represents the distance the motorcycle traveled in X hours. So this would be the car, and the motorcycle, I'm actually going to change the color, that would be 40X. And then to solve that, we need to determine when the number of miles the car travels exceeds the number of miles the motorcycle travels. So we need the car to be greater than the motorcycle, but the motorcycle is 40 miles ahead of the car. It has a head start, so we need to include that plus 40 as part of our equation. Oh, sorry, our inequality. If I left this off, well, 60x is greater than 40x right away if we're talking in terms of distance and time. But the motorcycle has a head start, so we want to know when it catches up. Let's keep this in color. All right, and what we can do, we can graph this. Again, you can graph this by hand. We're going to use the graphing calculator just so we can get a bit more familiar with that. So I'm going to go back to my y equals. I'm going to clear out what I have here. I'm just going to keep them color coordinated. So for the y2, that's the red one. So I'm going to put in my 40x plus 40. The blue one, again, for some reason is not working. So I'm going to work with green instead. It's a little bit more clear. So let's get rid of that 60x. Let's write that in green instead. So we have 60x. All right, so I'm going to type in my 60x. I'm going to hit graph. And what's going to happen is that this window is absolutely useless to me. I can't tell anything from this graph. All right, it's not very practical. It's not a good graph for me. So what I'm going to do is I'm going to show you how to change the window on the calculator. We already have a preview. This down here is already a preview of what my window should look like. There's a reason that I typed in these 0, 50, 100, and these numbers for you. So I'm going to use that as my basis. So to change the window, what you want to do is you're going to hit the window key, which is next to the y equals. We're going to hit window. And now I can change what my x and my y values are. All right, so that'll manipulate the x-axis and the y-axis. The x-min and the x-max are the lowest number you want on the x-axis and the highest number. Well, my graph goes from 0 to 6, so I'm actually going to go from -1 as my minimum, and I'm going to go up to 8. All right, as long as it's close and we want to go past that, we'll go with 8. The x scale is how large each kind of, we'll say, grid is. So we're going from like 0 to 1. So we can just leave it as 1. We don't need to change that. Now my y min and my max, my scale goes all the way up to 250. So I'm going to change the y max to 250. The y minimum, you can go with 0. I always try to go below that so I can see the origin on my screen. And since I'm going up by 50s, I'm just going to put in -50. Again, this is kind of up to you. You'll be able to manipulate it and you'll see as you go. And then my y scale, notice on our graph on the screen here, it goes up by 50s. So that's what I'm going to type in as the y scale. I'll put a 50 there. Don't worry about the x-res and the trace step. Don't worry about any of that. We'll just go with the minimums, maximums, and the scale. So now if I hit graph again, my graph is zoomed out and I can see this significantly better. I can see where these points actually cross. Once again, just looking at this kind of with the eyeball test, can't really tell exactly what's going on here. I have to remember what my numbers are. But what I can see is that my green line is going to go through 0, 0. So I know I have that point. It looks like 2 and maybe 120-ish. I'm saying that because I know that it is. So somewhere around here. And I'm just going to connect those as best I can. My red line, I know starts at 40, right? That's my y-intercept. And again, because I already know the answer to this, just go with it. It's going to cross at that 2 120 point. Let me try that one more time. It's going to cross right there and look something like that. We're not worried about the graph per se here. We're worried about how to interpret the graph and what we're trying to do with these actual numbers. This point here where they intersect is my key point. Right? I'm trying to find out when will the car be ahead of the motorcycle, and the car is the green line. So we're looking for when is the green line above the red line. All right, that means it's greater, right? It's creating greater values as I go right on the x-axis. So it looks like from 2 or x equals 2, and then anything above that, that's where my car is going to be ahead of the motorcycle. So the question, when will the car be ahead of the motorcycle? I would say after 2 hours. Don't stress yourself out about too much of the details with what's going on here. The main part of this section, you want to just be able to learn how to type things into the calculator. You want to be able to learn how to manipulate your window, and you want to be able to interpret what graphs look like in terms of finding solutions when your graphs intersect. So in example 1 earlier, we were looking at equations, so we cared about the x value at the intersection points. In part 2, or example 2, we're looking at inequalities, so we're looking for either greater than or less than, and then interpreting that information. So hopefully some of this is sinking in and it's making a bit of sense within class and going through these videos, practicing with the calculator. You will get more familiar with this with each passing practice example. So hopefully you're making progress.